Hello, welcome to Math 253 Calculus 3 here at Cañada College. My name is Lapuz, and in this video, we will be looking at checkpoint 6.60. Here we have a cast iron solid ball given by this inequality: x squared plus y squared plus z squared is less than or equal to 1. Temperature at a point or region of the ball containing the ball is going to be T. That's a third times x squared plus y squared plus z squared. The heat flow across the boundary of the solid. Find the heat flow across the boundary of the solid if the boundary is oriented outward. So we're looking at the whole sphere here. So as we're looking at the whole sphere, we want to parameterize the sphere. And we can do a couple of things. We can find two separate parameterizations for the sphere, but I think that's a little bit too complicated. So we'll parameterize the sphere using spherical coordinates. So this is a spherical coordinate parameterization. And what is that going to look like? We can use phis and thetas. Rho is going to be fixed at 1. So we don't need to worry about that. We can use phi and theta. But generally, we've been using u's and v's, so why don't we stick with the u and v business? So u and v. And for the first one, let's use cosine v. Let's imagine that u is phi and v is theta. Okay, so this is going to be cosine v, that's cosine theta, sine u, and then sine v, sine u, that's sine theta, sine phi, and then rho cosine phi, so that's u. Okay. So let us find the derivatives with respect to u. So with respect to u, the derivative of sine is cosine, so this is positive. Cosine v, cosine u. The derivative of this with respect to u, that's again the sine, so this is going to be sine v cosine u. And with respect to u, the derivative of cosine is negative sine u. All right, now let's take the derivative with respect to v. The derivative of cosine is negative sine, and the derivative of sine is positive cosine. And there are no v's in this last one, so that's going to be 0. All right. We will need to take the cross product of u and v, or ru and rv. Let's see if this will turn out nicely. This is going to be 0, and this is going to be sine squared u, negative. So that's going to be negative cosine v sine squared u. It's negative, so make that into a positive. Now the middle term is going to be 0 minus minus, so there's a negative from the j component in your cross product, and then there's another minus, and then here is negative negative, so that's a plus. So negative 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 negative, it'll end up being all positive. And we have sine v and then sine squared u again. And then in our last component we have cosine squared v, cosine u, sine u, minus negative sine squared v, and then sine u, cosine u. All right, I think this might be worth simplifying a bit. And so let's go ahead and simplify this a bit. So here we have well, nothing to simplify here. Cosine V sine squared u, sine V sine squared u, and here we have cosine squared and sine squared after you factor out cosine u sine u. All right, so this is our cross product. To guarantee that this has an outward orientation, we want to make sure that that we have the sine and the cosine kind of following the systems here. And I think if we take away a sine u, we'll have cosine. Well, we could try to put some points in. So let's say at this point here we have theta is equal to 0 and phi is equal to pi over 2.